Good day everybody, my name is Emmeline Jabah Anak Guyang from AS1204F. Today, my group mates and I, Jesiani Ensi and Widya Alia, will be presenting a video about the basic chromatography for CHM256.
Basic chromatography is a technique for separating mixture components. The mixture is transported through a fixed or stationary phase by the flow of a mobile phase. Chemical components in complicated mixes are commonly separated, identified, and determined. The mobile phase can either be a liquid or a gas, while stationary phase is either a solid or a liquid. Next is the principles of chromatography. Like I have said in the introduction, chromatography is a technique to separate chemical components or compounds in a complicated mixture. The several different components which is distributed between two phases proceeds in a specific direction, which is hydrophilic and lipophilic. Each compound must be separated in order to identify it using other analytical methods, both qualitatively and quantitatively. Let's talk about the theory of chromatography. The stationary phase is a solid or liquid substance that remains fixed in place during chromatography process. Its function is it acts as a constraint on the components of mixture, slowing them down to move slower than the mobile phase. The interaction of components with the stationary phase is through absorption or partitioning, which affects their movement through the system. One example of the stationary phase is the chromatography paper itself. Next is the mobile phase. Mobile phase is a liquid or gas that carries the components of mixture through the chromatography system. The function of a mobile phase is it carries the components through the stationary phase and separating them based on their reactions with the stationary phase. The interaction is the components interact with the mobile phase through solubility and partitioning, which affects their movement through the system. One example is water.
The definition of planar chromatography is a separation technique in which the stationary phase. The use of paper chromatography is to have mixture into individual components. Next, TLC chromatography is to spread organic compound and check purity of product. Column chromatography is a technique of separation of mixture occur on stationary phase that held in a narrow tube. The uses of column chromatography are separation, identification to check purity. For industry application, it used in food industry, chemical, and forensic chemistry.
Here is the example of paper chromatography methodology for food dyes. In order to conduct this experiment successfully, we will need a filter paper or chromatography paper strips. Other than that, we also need solvents such as water, ethanol, or mixture Standard food dye solutions for comparison are also needed. Capillary tubes or micropipettes for sample application and developing chamber, which is a tall glass or plastic container with a lid, is also important. First of all, you have to cut the filter paper or chromatography paper into strips of uniform size. Mark a pencil line near one end of each strip where the samples will be applied. Choose a suitable solvent or solvent mixture based on the polarity of the food dyes being analyzed. Common solvent systems for paper chromatography include water or alcohol mixtures of varying concentrations. Prepare small volumes of each food dye solution to be analyzed. In this experiment, a purple, green, and yellow color was used. Using capillary tubes or micropipettes, apply small spots of each solution onto the pencil line on the paper strip. Allow the spots to dry completely. Insert the paper strip vertically into the chamber, ensuring that the pencil line is above the solvent level. Close the chamber to prevent solvent evaporation and allow the solvent to migrate up the paper via capillary action. Allow the solvent to move up the paper strip until it reaches near the top, which is too close to the edge of the paper, and remove the paper strip from the chamber and mark the solvent front immediately. Measure the distance traveled by each spot from the origin to the solvent front. Calculate the RF value for each spot using the formula. The RF values obtained from our experiment will be compared with those of standard fruit dyes to identify and confirm the presence of specific dyes. Here is the results of our experiment. Based on this, we can see what components present in each of the colors. The RF values for each of the colors has also been counted and obtained.
Purple, green, and yellow coloring food are used for this experiment. As the solvent moves up the paper, the individual components of the mixture separate out because each component travels at different speed due to its interaction between paper and the solvent. For RF, a higher RF value indicates that the substrate has a stronger affinity for solvent and moves further up to the paper. A lower RF value suggests that the substrate interacts more with paper and remains closer to the starting point. The factors that may affect RF, like solvent, paper type, temperature, and concentration. Chromatography is based on the principle which compound in mixture applied onto the surface or into the solid and fluid stationary phase in separate